Hey guys, so today we are going to solve linear systems by graphing. So what that means is that to solve is simply to look and see where do they cross, where do they intersect. And so in this case, these lines intersect right here at this point. And that point, we always write it as an ordered pair, so that's -1, -1. So at -1, -1, that's where they intersect. So this is the solution to these two lines. Same one over here. Looks like this one's a little off-centered. So we go over 1.5 because we only go about halfway. So the x value is 1.5, and then you go up 1, 2. So if the lines are already created for you, you simply look at where they intersect. If they are not, we need to go ahead and follow these directions. If we are given examples or equations here, we need to follow these directions. So to solve a system of equations by graphing, step 1, you want to make sure both equations are in slope-intercept form. So that's in y equals mx plus b. Please make sure you pause the video here if I'm going too fast so you can get everything written down. Then we get to step 2. Step 2, we would graph the first equation. Step 3, we graph the second equation. And then you find where the 2 points cross. So once they're graphed, like this one here, you find where the 2 points cross, your x and y. And that's all you have to do. So for example 1, if you have graph paper, this is really going to help you out. If you don't, you can go ahead and sketch this. So when we're looking at this here, the first one, I'm going to go ahead and do an orange. So I'm going to write it. I have room right here. When you're graphing, it will also help to have a ruler. Go ahead and pause it. If you have a ruler, find a ruler or find something even that has a straight edge to it. You will need that to have your exact point. Okay, so when we graph, we always graph the y-intercept first. So y-intercept is b value. The b value is -2. So I'm going to go ahead and go to -2 and put a point right there. And then our slope is this negative sign, which is a -1. Remember, slope always needs to move in two directions. So if it's not a fraction, you make it a fraction by putting it over 1. Negative means to go down, 1 runs to the right. So from this point here, we're going to go down 1 and go to the right once. You only need 2 points to draw a line. So we're going to connect those 2 points, line them up. Lines go on forever and ever in both directions, so put your arrows at both ends. Like I said, please pause the video right here if you need to get caught up. If you're caught up, we're going to go ahead and do this second equation here. Always do the y-intercept first, so the y-intercept is 3, and the slope is 2 over 3. Choose positive, that means you go up 2, and you always run to the right 3. So I'm going to first graph 3. And then from this point, I'm going to move up 2 to the right 3. So go up 1, 2, 1, 2, 3 to the right. 2 points makes the line. Connect those, and we'll see where they intersect each other. Okay, so it looks like these intersect at this point right here. Let's go ahead and look what this point is. It is -1, -2, -3. And we don't move up or down, so -3, 0. This is the solution. So I just double checked my, when I drew the lines, this actually should have crossed right here. And this is why it's so important to be very precise. So So instead of this being a 0, it's actually a 1. It makes a huge difference. I'm going to show you why. So what this solution means is that if I plug this solution, this is an x and y value, into these two equations, you will they will equal each other. So I'm going to only do this once to go ahead and show you guys. So I'm going to take this first equation, y equals negative x minus 2. So if I replace y with 1, write the negative symbol, negative 3 minus 2. Okay, so when I solve this, a negative and a negative make a positive. 3 minus 2 is 1, and you can see we have 1 on this side. So this is the solution because when you plug in this point, 1 equals 1. I'm going to go ahead and do this with this other equation here. I'm going to take y equals 2/3 x, that's times x because they're next to each other, plus 3. So y is 1, 2/3 times negative 3. Put it over 1 as a fraction. So when I multiply this, I get negative 6 on top over 3. Still have the plus 3 at the end. Negative 6 divided by 3 is negative 2. Negative 2 plus 3. And negative 2 plus 3 is a 1 also. So these equations, no matter if I put it into this one or this one, I get the correct answer. But would it kept the 0, it wouldn't have worked. Each side would be different, and so you would know that is not a solution. So that's how you can go back and check your work and make sure it works. So we're going to go ahead and do another one. Let's start with this top one. So always start with b. b is negative 2, and we'll graph negative 2 here. The slope, always graph next. It's in front of the x, so it's a 1. It always needs an upward movement and a sideways movement, so we put a 1 underneath it. So that means we go up 1 to the right 1. Up 1 to the right 1. You might want to add a few more points to ensure that you have a straight line so you don't make a mistake like I did on this other one. So although 2 points connect to make a straight line, it really helps you visualize where your line should be if you are making a lot more points. So I'm going to connect those points. These are arrows, give them arrows at the end because it's a line, and then we'll do the second one. Always start with the y-intercept, which is 1. Y-intercept is 1 right here. Slope is negative 2. Oh, excuse me. Okay, so negative 2. If it's a whole number, you always put 1 under it. Since it's negative, we're going to go down 2 to the right 1. So down 2 to the right 1. And actually, we landed right on this point, so we know that's the line of intersection, which is the solution. So on this one, our solution is at that point here, which is 1, negative 1. I'm going to do this one more time. I'm going to plug these two into these, and you should get the same answer for each one, so you know it's a solution. So if I take y equals x minus 2, y is negative 1, so make sure you put that in the right spot. 1 is for x. 1 minus 2 is negative 1, which we have over here. Those equal each other. That point works as a solution. If I use the other equation, y equals negative 2x plus 1, make sure you replace y with the negative 1. Use parentheses. You don't want to make this number into negative 21. It's negative 2 times 1. So we have negative 2 times 1 is negative 2 plus 1. Negative 2 plus 1 is negative 1. And these also equal each other. If we were to use any other point, these would not equal each other, so you would know it is not a solution. So if you were given a list of points to try, you would just plug them in like we did right here. You would plug the y value in and the x value in, solve it, and see if they equal each other. So just to show you what that means, I'm going to give you an example right here of one that wouldn't work. So this point, let's go with 2, 0. It's only on the orange line. So if I plug 2, 0 in to, let's do this here, I use the point 2, 0. You don't have to write this down, I just want you to follow. Once again, 2, 0 is only on the orange line. So if I plug it into this equation with the 0 here and the 2 here, remember this is the orange line, 2 minus 2 is 0. It totally worked. Okay? But if I plug this point in into the other equation, whoops, y equals negative 2x plus 1, we're going to put the 0 in for y. The x is going to be replaced by 2. When I solve it, I get negative 4 plus 1. Negative 4 plus 1 is negative 3. They do not equal each other. So since they don't equal each other, this cannot be a point for a solution for both lines. There's only one solution that will work for both equations. All right, let's just try a couple more. So this one here, they are not written in y-intercept form. They always need to be written as y equals mx plus b form. So the b has to be isolated. So I'm going to pause it right here. Okay, so I'm going to take that first equation. We want it in y-intercept form, so we want the y isolated. So first we need to move the x over. Now if you notice, the 6 doesn't have a variable with it, so the 6 is the b. We're going to end up pushing it over to the back because the x needs to be in front of it. So when we do that, to get x onto this side, we have to subtract it because it's a positive x. And we have negative 2y left on this side. Don't combine these are not like terms, but because x needs to be first, I'm going to put the negative x here. And then I'm going to put, this is just a 6, so it's a plus 6. But the y is still not by itself. We have a negative 2 with it. So to get rid of that, it's being multiplied by negative 2, so we're going to divide by negative 2 to get rid of it. Everything has to divide by negative 2. Keep in mind, next to the x is an invisible 1. So what we have left is y equals, 2 negatives make a positive, so we have 1/2 x, and 6 divided by negative 2 is negative 3. So that means that our b, our y-intercept, is negative 3. I'm going to put it in orange. So b is negative 3. So 1, 2, 3. You could also use different color highlighters to make them stand out if you don't have different color pens. And our slope, see from this first equation, you cannot tell that the y-intercept is negative 3. That's why we need to put it in slope-intercept form so we can see it. So the slope is 1/2. 1 is positive, so we go up 1 and to the right 2. So up 1, to the right 2. This time I'm going to do a few of them. Okay. Graph those, connect those points. Remember to pause this if I am going too fast. All right, let's go ahead and write the other one. So the other one we have is 4y plus 3x equals 8. Well, if we want y all by itself, we're going to have to get rid of the 4 and also the 3x. Let's move the 3x over first. So I'm going to subtract 3x, move it all to over. So now 4y is still left here. The 3x is now gone. These are not like terms. We want to write them here. Remember, we always write the x value first. So negative 3x is first. And the 8 is a positive 8, so we're going to put plus 8. We still have to get rid of this 4. So since it's being multiplied, we divide. Everything divides by 4. So what we have left, we like fractions with slopes because that tells you the movement, so we're going to leave it like this. And for this, we'll simplify it. 8 divided by 4 is 2. So this is our equation here, and we can graph it. Always start with b. b is 2, so we're going to go to 2. And then slope is, we always give the negative sign to the top because that will tell us to move down. And then 4, we run to the right. So from here, we're going to go down 1, 2, 3, and run 1, 2, 3, 4. And we actually touch the spot where they intersect. So we can connect those. And the solution, there's only one point where they touch, is at 1, 2, 3, 4. And then we went down 1, negative 1. So there's our solution. Our next one, we're going to go ahead and write this one out. So we have slope. We always start with b. b is first. b is 3. So we start here at 3. And then our slope is 2. Always put it over 1 if it's a whole number. So that means go up 2 to the right 1. So up 1, 2 to the right 1. We'll do this a couple times. Draw a straight line. And the other one we can graph, always start with y-intercept, which is b, and that's a negative 4. So we'll go down here to 1, 2, 3, 4. Our slope is 2 again, so put it over 1. So we go up 2 to the right 1. So we're going to go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. We can connect those points. Maybe you noticed without even graphing, if you notice this without graphing, that our slopes are the same. That means that they will never cross paths. So there are no solutions. No solutions because these are parallel lines, which means they have the same slope. And they will never intersect each other. That should be an S. Okay. Last one. So last one, first one set up pretty easy for us. B is 3. So we're going to go to 3. Then we're going to do the slope. Slope is 2. Put it over 1. So we're going to rise 2, run 1. Rise 2, run 1. Rise 2, run 1. I'll do a couple more. Connect the dots. And then this one we have to rearrange. It's not in the right form. We need to get y isolated, so we're going to we always move this x value over first, and since that's a positive, we can subtract it to move it over. Now that that's moved over, we have negative 3y left. Remember, when we're writing things in y-intercept form, we always put the x value first, so we're going to write this first, negative 6x. The 9 is positive because there's no sign. So then y is still not isolated. We have to get rid of the negative 3. So to get rid of the negative 3, we are going to divide by negative 3. Everything gets divided by negative 3. So y is now left alone. Negative 6 divided by negative 3 is a positive 2. 9 divided by negative 3 is a negative 3. So if we now look at our b value, it is negative 3. So we're going to go down here to 1, 2, 3. And our slope is 2. Put it over 1. So up 2 over 1. Up 2 over 1. Up 2 over 1. And you can see already without us finishing the graph that these lines are also parallel. So once again, there will be no solution to this because they will never touch. All right, you guys are now ready to begin the homework.